Hi, folks. This is the example number 11 from the 9.2 homework, okay? Now, unlike the last example, example 9, that one is definitely fair game for an exam, right? But 11, and I know it's the same with 10 and 12, these questions are long. I'm not going to ask them on an exam, but I do want to go through it, kind of talk through the process. I think there's a lot of skills that can be transferable to other questions here that are worth listening to, okay? But I totally get it if you stop watching now, and that's okay too. All right. So, an influenza epidemic has spread through a community of 18,000 people at a rate proportional to the product of the number of people who have been infected and the number who have not been infected. Suppose 120 individuals were initially infected and 360 were infected 10 days later. How many people will be infected after 20 days, and when will half the community be infected? All right. So this is a really great example of when we have our logistic growth. Okay. So we're going to use what we have in our notes, logistic growth, to help us come up with our equation, but we're also going to be able to pick out our initial conditions from the question. Okay, so we're actually going to start the very same way we did for the previous example. We're going to look up our information and we're going to write it all down so we have it all in one place. Okay, now it says that initially 120 people were infected. Okay, so what that means is that the population that was infected on day 1 or day 0 was 120. Okay. It also says that 10 days later, 360 people are infected. That's the same thing as seeing P of 10 equals 360. Okay. Now, unlike the last question, we're looking now at logistic growth. So if I go back to the notes, I see that we have logistic growth, that is our dp dt equals, and it looks kind of similar to what we did in the last example. Instead of k times m minus p, though, there's also a constant on the outside or a population on the outside. Okay. So this is like the number of people who have been infected, and then this is the number of people who have not been infected yet. So let's actually put in a number for the M though, because there are 18,000 people in the whole population. Okay. All right, so here is our differential equation, and here are our initial conditions. And so let's go ahead and start off by finding the general solution. Okay, we're not going to find the particular one yet. We'll find our general one first, and then we'll use our initial conditions to find the general solution. Okay. All right, so let me copy that question down again. dp dt equals k times p times 18,000 minus p. Okay, so I'm going to separate and I'm going to integrate. I'm going to divide over the 18,000 minus p and the p. So this is now on the same side as the dp. And I'm going to multiply the dt over to the other side. K dt. Okay, I've separated. Now I get to integrate. So the integral of 1 over p 18,000 minus p dp equals the integral of k dt. Now, just like our lecture video, this is actually one of the integrals in the table. And so if we use our table, here's what we get. 1 over 18,000 natural log of p over 18,000 minus p. And when we integrate the right-hand side, we end up with kt plus, I'm going to use the letter D for right now, but D is a constant just like C, just like our A from the other video, okay? And now I'm going to multiply both sides by the 18,000. Natural log of P over 18,000 minus P equals 18,000 KT plus 18,000 D. Right? Now I'm going to let 18,000 K, I'm going to call that B. It's some number, I'm just going to let it be B. Okay. Similarly, 18,000 D is a number, so I'm just going to rename it C so that I don't have to write as many things. Okay. All right. This is going to now allow me to exponentiate both sides. So that's when I do e to the power of both sides. So I'm going to have e to the power of that natural log equals e to the bt plus c. All right. Look at how much less ink we already have on that right-hand side. That's why we like to sort of rename constants if we can. Okay. Now, things are starting to get a little bit better. E and natural log cancel. So on my left-hand side, I just have P over 18,000 minus P equals e to the bt plus c. Okay? Now, to get my general solution, I need to get P all by itself. So what I'm going to do is take this denominator, multiply it to the other side. And I'm going to get P equals 18,000 e to the bt times e to the c minus p times e to the bt e to the c. Okay, so remember when we have those exponents that are added, I can split this into the e to the bt e to the c. Okay. All right, now I'm going to take this term that has the p and I'm going to add it to the other side. And then I'm going to factor out the p that's now in both terms. So that's going to give me p parentheses 1 plus e to the bt e to the c equals 18,000 e to the bt e to the c. All right. Now, to get P all by itself, I'm going to divide both sides by the thing that it's multiplied by. P equals 18,000 e to the bt e to the c over e to the bt e to the c plus 1. Okay. Now I'm going to multiply by a very clever choice of terms. And as long as I'm multiplying and the top and the bottom are the same, it's like multiplying by 1 and it's totally fine. So what I'm going to multiply by is e to the negative bt e to the negative c over e to the negative bt e to the negative c. Okay. Now when I do that, that's going to, the e to the bt and e to the negative bt are going to cancel. And e to the c and e to the negative c are also going to cancel. So my numerator is just 18,000. Okay. Now, e to the bt, e to the c times e to the negative bt, e to the negative c, that's going to go to 1. Plus, I'm going to have e to the negative bt, e to the negative c. Okay. Now we're going to make one more substitution. We're going to let e to the negative c, we're just going to call that a. And so that's going to give us a solution, a general solution of 18,000 over 1 plus a e to the negative bt. Okay. So here is our general solution. Let's kind of squeeze it all back in. Look at all that work we did, but all of that is for our general solution. Now that we have our general solution, we got to find our particular solution using our initial condition, okay? Okay. So let me copy my general solution up here. P equals 18,000 over 1 plus AE to the negative BT. Okay. So now what we want to find is A and we want to find B. Once we find A and B, that will give us our particular solution. Okay. So the first thing I'm going to use is that P of 0 is 120. And so that's going to give me 120 equals 18,000 over 1 plus AE to the 0. And I know that AE to the 0 is 1. And so that's going to give me 120 equals 18,000 over 1 plus A. Okay. Now I'm going to multiply the 1 plus A to the left-hand side, and I'm going to divide the 120 to the right-hand side. That's going to give me 1 plus A equals 18,000 divided by 120. And I believe this gives us 1,500. Okay, so 18,000 divided by 120 gives us, oh, not 15,000, 150. Super glad I double checked that. Okay, so we get 150 for our A, and or for our 1 plus A, that means A is 149. Okay. Now I'm going to box this off because this is what we're going to put back into our particular solution. And we're going to use that along with the second initial condition to find our B value. Okay. So this is going to be P equals 18,000 over 1 plus 149 e to the negative BT. And I know that after 10 days, 360 people are infected. So this means 360 people are infected after negative 10B. So we're putting in 10 for our little t. Okay. Now, I'm going to go ahead and do something similar. I'm going to divide my 360 to the other side, and I'm going to multiply this denominator to the left-hand side. And so let me just draw a little squiggle so when you go back and look at it, you don't think they're all together. But this is going to give me 1 plus 149 e to the negative 10b equals, let's see, 18,000 divided by 360 gives us 50. Okay, I'm going to subtract the 1 and I'm going to divide by the 149. This is going to give me e to the negative 10b equals 49 divided by 149. And just like I did in the last video, I'm going to leave this as a fraction and turn everything into a decimal at the end so I don't get something wrong because I rounded too early. Okay? I've got a natural log both sides. This is going to help me get rid of the e on the left-hand side. And so natural log and e cancel. I get negative 10b equals natural log of 49 over 149. And now when I divide by the negative 10, let's see, natural log of 49 divided by 149. And then that whole thing divided by negative 10 gives me 0.1112 for my B value. Okay. So let's put everything in our A and our B together to get our particular solution. So P equals 18,000 over 1 plus 149 e to the negative 0.1112 t. Okay, this is our particular solution. All right. So we've done all of this work, right? We found our information, we found our general solution, we found our particular solution. Now we got to figure out how many people will be infected after 20 days. So we're going to plug in 20 for T. And then we're going to say, when will half of the community be infected? And we're going to have to solve for a T. Okay. So we're in the home stretch. All right. So let's go ahead and find out how many people are infected after 20 days. That's going to be P of 20. So I've got 18,000 over 1 plus 149 e to the negative 0.1112 times 20. And I'm going to carefully plug that all into the calculator. And I get 1,051.515 people are infected after 20 days. Okay. Now, the trickier part, I got to find out when I'm going to have half the number of people infected. Okay. So, how do we do that? Well, in for our P, we're going to put 9,000 because 9,000 is half of that 1,800. And so I'm going to get 9,000 equals 1,800 over 1 plus 149 e to the negative 0.1112 t. And I'm going to use my algebra skills to solve for t. Okay, so we'll do what we did similar before. We're going to multiply that denominator over, and we're going to take 18,000 and divide it by 9,000, which will actually give us 2. Okay. I'm going to subtract 1, and I'm going to divide by 149. So I'm going to get e to the negative 0.1112 t equals 1 over 149. Now I'm going to natural log both sides. And this will get me to negative 0.1112 t equals natural log of 1 over 149. Okay, last step, I'm going to divide by that negative value, and I'll get natural log 1 divided by 149, all of that divided by negative 0.1112, and I will get 44.9995 days. So basically, on day 45, half of the people are going to be infected. Okay, so let me get this all on one page for you. I know this was a lot of work, a lot of algebra, but I'll post these notes under the 9.2 homework or 9.2 stuff, so you can just find it over there. And thanks for tuning in.